that's actually what we want to look at in terms of the care property as you start to develop mechanical properties. Now, near room temperature, because we can't go sub-ambient, we you're not going to pick up much change. But,
So much better now.
Yeah. You got the like cracking sound before, and now it sounds better.
oh, well, that's good.
It is,
Oh,
yeah.
really?
Yeah.
That's
Good.
surprised. So every time he stopped the wheel, I have to step aside.
Because of the like a grinding.
No, I
because
just hate
when
the
you start
noise.
the motor because of the motor twist. We get like cracking sound.
Like some
because
sort of
twist
metal
over
binding or something.
Yeah.
Yeah. I don't know.
Yeah, that would, might do the... When was the last time you changed the seals on it?
Not too long ago. Like about, I would say about 1 month.
Oh. Before we go any further. Oops.
Oh, to remove the air or not?
No, I just wanted to get this rubber pad in here. Swoop. Just keep the resin or whatever off there.
So for calibration, what is the period that for your calibration is like? How many days?
Again, it depends on the amount of use, and I always calibrate before you do a specific study, and otherwise once a week.
Once a week.
Should we keep like all the study in the same calibration period or doesn't matter?
And when you're doing an aging study like this, where you'd be doing it, I would always do a calibration before every data set, just in case there's some, minor change or whatever. Because that when you do the calibration, it's set the baseline, and that baseline should always be in effect the same.
Right. Okay.
You're not going to get kind of shifts you do in DSC, but it's the same principle. You'd like to be starting from the same point now. And in the case of calibration and DSC, you got a floating baseline. From this, that baseline doesn't float nearly as much.
So you think every test is good or every week?
No, when you start doing it every test, you're going to start.
That's a lot of different.
First of all, it takes a lot of time. Secondly, I'm not so sure you're not starting to introduce more error than you're eliminating, just because every time, even if it's a very minor change, it's going to be a minor. I don't know. I don't see any point in it, I guess. Is what I'm saying.
How about the consistency of the rheometer? Like based on your experience, like between the same type of material, what is the consistency between
We
run to
will
run?
see essentially the same results on material, if the material is essentially the same. We've
about
done it 3 years later.
Like the
You
values,
get-
like the viscosity value or G gram or G gram value, is there any shift?
No,
No.
because you're measuring torque basically. I mean, it's a pretty constant. Now you will get a change if you get a little change in fiber volume or something like that, but that's actually material.
Representative of the material.
Yeah.
So what percentage can I expect from the rheometer? I mean, the change in percentage between the values. I mean, what is the allowable range for? Let's say 5% is the variation between two samples. So should I say this is because of the rheometer or because of the samples itself?
Most of the time because of the sample size.
That's what I said.
It's